Hello, ninth class students. The next chapter which I am going to start for you is atoms and molecules. See, when it comes to SSC examination, this chapter is very important, because in the next year you have a chapter by name structure of an atom, which is again a high weightage chapter, and when it comes to intermediate, again this chapter repeats. Okay, so the foundation which you will be receiving in the ninth class is going to help you understand the chapters in the later stages or the advancement of the topics in atoms and molecules. Okay, so I'm going to start atoms and molecules. It's a bit lengthy chapter and I'll be going in very detail for this one, so watch the videos which I'm giving you now.
Hello friends, this video on Atom and Molecules part 10 is brought to you by examfear.com. No more fear from exam. So let's take some simple compounds. We'll use the formulas which rules we just told you, 3 rules. First one is the charge is balanced and the metal is written first. In case of polyatomic ion, it is enclosed in the braces. Okay, let's first write some chemical formula for simple compound. See, simple compounds can be made of 2 or different elements. They are called binary compounds actually. Okay, for example, NaCl, HCl, okay, H2O, H2S. These are all simple compounds. CCl4, MgCl2, calcium oxide, Al2O3. All these are simple compounds. If you see here, they are made of only 2 atoms: NaCl, HCl, HO, HS, CCl, MgCl, CaO, AlO. Okay, let's write the formulas for this. NaCl, plus charge minus charge, 1 1. So this becomes NaCl. Pretty easy. So in this case, if you see the first rule, the charge is balanced, yes. Metal is written first, yes. This is not polyatomic, so we'll not go for third rule for all these. We'll go for only first 2 rules. And for this set, let's write for HCl. It's plus 1, minus 1. You charge balance, you get HCl. H2O, plus 1, minus 2. You get 2 here, you get 1 here. You get H2O. Similarly, H2S, plus 1, minus 2. What you get is H2S. CCl4, CCl, minus 1, plus 1. Right? Sorry, carbon is 4. So this becomes 1, this becomes 4. So what you get is CCl4. Let's try for others. MgCl. Magnesium charge is 2, chlorine charge is 1. You get 1 here, you get 2 here, you get MgCl2. Calcium oxide, calcium charge is plus 2, this is minus 2, this is 2, this is 2. This becomes Ca2O2. 2 we can actually take cancel, it becomes CaO. Al2O3, this is aluminium, this is oxygen. Aluminium plus 3 charge, oxygen minus 2 charge. This becomes 2, this becomes 3. You get Al2O3. So that's how you write simple compounds. Okay? Pretty easy. You can just try, it's very easy actually. Let's take some more questions now. Formula of carbon tetrachloride, we just saw it was CCl4, just now we have seen that. So there's a carbon with the plus 4 charge, with the minus 1 charge. So this goes like this 1, CCl4. Magnesium chloride also we saw, magnesium plus 2 charge, Cl minus 1 charge. Swap it, this becomes MgCl. Aluminium oxide also we have seen, AlO plus 3 plus 2 becomes 3 becomes 2. It becomes Al2. Sodium nitrate. Sodium plus 1 charge, nitrate minus 1 charge. This becomes Na, NO3 with the braces, 1 here. But since it is just 1, you can actually remove the braces. Calcium hydroxide, calcium OH minus 1 plus 2. This becomes 1, this becomes 2. This is calcium. OH is a polyatomic ion, CaOH2. Similarly, sodium carbonate. Sodium carbonate, NaCO3, Na with the plus charge, CO3 is a minus 2 charge. This becomes 1, this becomes 2, this becomes Na2, CO3, the braces. Since it is 1 here, you can remove the braces. Okay, then ammonium sulfate, NH4 and SO4. This is minus 2, this is plus 1. This becomes 2, this becomes 1. This becomes NH4, 2, SO4. Since SO4 is 1 here, you can remove the braces from SO4, but you cannot remove it from NH4. Please note that this has to be in the braces. For example, COOH2, it has to be like this. You can't write COOH2. This is wrong. This is right. You should have this bracket. Right? In this case, if you see, both are multi-ion. Ammonia is multi-ion, SO4 is multi-ion. Both ammonia and sulfate are multi-ions. But for sulfate, since it was 1, we didn't write the braces. We actually remove it out. But for ammonia, since it is more than 1, the bracket is required. Here also, OH bracket is must. Okay. We can also take aluminum sulfate. One example. It's right here. Aluminum sulfate. So aluminum is plus 3, sulfate is minus 2. This becomes Al2SO4. Please note, there is a bracket here. So we are following all the rules. First rule, the charge is balanced. This is the charge is balanced with this convention. The metals are written first. Yes, the metal is written first in all the case. We are writing metal first. Right? Also, if you see the name also, first you will have metal. And the third rule for the polyatomic, yes, in case we have polyatomic ion, we are making sure it is in the bracket if it is more than 1. Okay. Let's take some more numericals to clarify our concepts. You have to write down the formula of sodium oxide, aluminum chloride, sodium sulfide, magnesium hydroxide. Let's write for sodium oxide, sodium and oxygen. Sodium is metal, oxygen is non-metal, sodium is written first. Let's do the valency balance. Sodium is plus 1, oxygen is minus 2. So this becomes 2, this becomes 1. This is Na2O. That is the formula. Let's do for aluminum chloride. Aluminum is metal, chlorine is non-metal. Aluminum is written first, chlorine is written second. Aluminum has a charge of plus 3, chlorine has a charge of minus 1. Let's do a balance. This becomes 1, this becomes 3. You get AlCl3. Then we have sodium sulfide. We have sodium, we have sulfur, sodium with the plus 1 charge, sulfur with the minus 2, sodium is metal, written first, sulfur is non-metal, written next. Let's do the charge balance. You get Na2S. Magnesium hydroxide. Magnesium is metal, hydroxide OH. Let's put the braces here only. Charge balance plus 2 minus 1. So what you get is MgOH. Pretty easy. Let's take some more examples. Let's write down the names of these compounds. Al2SO43. We just wrote the chemical formula for this. And this is Al is aluminium and SO4 is sulfate. So you can just write aluminium sulfate. All these numbers we need not worry about. These are all taken care by valency. Ca is calcium and Cl2 is chloride. Right? You do not worry about these numbers. Right? K is what? Potassium. And why we are not worried about these numbers? Because these numbers have been taken care by valency. And SO4 is again sulfate. Here again NO3 is again a polyatomic ion. K is potassium again. And NO3 is nitrate. So it is potassium nitrate. CaCO3. Again CO3 is again a polyatomic ion. C is calcium. And this is carbonate. So the only challenge here is to understand which is polyatomic ion in case it is one and the basis is removed. That is the only tough scenario. Else if the basis is there, you can actually know this is aluminum, this is sulfate, this is calcium, this is chloride, this is potassium, this is sulfate. But in these last two cases, nitrate and carbonate, right, that thing was not given. Okay, the charge, I mean the bracket was not there, so it was a little difficult to understand. This is with experience, with practice, that NO3 is again a polyatomic ion and CO3 is also a polyatomic ion. Don't write the name as calcium, carbon, oxygen. Okay, you have to understand that CO3 is a polyatomic ion. Some of the polyatomic ion is CO3, 2 minus NO3, 1 minus SO4, 2 minus OH, 1 minus anything else I could think of. Yeah, mostly you will see these kind of polyatomic ion. Okay. What is meant by chemical formula? See, chemical formula we just told is a symbolic representation of its composition. Symbolic representation of composition. Right? For example, water is H2O, sulfuric acid is H2SO4, methane is CH4. So it will tell you what is the actual composition. Right? It shows the constituent elements and the number of atoms also. Right? Numbers of atom of each combining element. For example, here 2 hydrogen atom, 1 oxygen atom. Right? Calcium carbonate, 1 calcium, 1 carbon, 3 oxygen. Al2SO4 3, 2 aluminum and 3 sulfate. HCl, 1 hydrogen, 1 chlorine. So chemical formula actually is a symbolic representation of its composition. So these 4 words are pretty important. Symbolic representation of composition of a given molecule. How many atoms are present in H2S molecules and PO4 3 ion? See, H2S, sulfur has 2 hands in this case, and 2 hydrogen atoms are bonded. So if you see here, there are 1, 2, 3 atoms. So 3 atoms in H2S molecule. Please note, this is H2S is a molecule. Hydrogen, sulfur, hydrogen, these are atoms. PO4 3 minus. So if you see here, I'm not sure about the bond. So since you don't know about double bond and single bond, so I've not represented that. Just see 1, 2, 3, 4, 5 atoms in phosphorus. So it will be 5 atoms in PO4 3 minus ion. Note that this is ion. PO4 3 minus, whole thing is ion. Okay, this is also a polyatomic ion. Example is S3PO4. Okay, I think in this case 1 is double bond. Not very sure on this, yeah, but I think one is double bond, others are all single bond. Yeah, because phosphorus has typically 5 hands, 5 valency, 1, 2, 3, 4, 5, yeah. Okay. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching. Hello friends, this video on Atom and Molecules part 11 is brought to you by examfear.com. No more fear from exam. So till now we have seen the molecular mass of atoms. For example, we know the molecular mass of hydrogen, carbon, oxygen. These things we know, right? These are all in units. But most of the things around us is compound. For example, water, carbon dioxide, sulfuric acid, ammonia gas, methane gas. All these are compounds. And we want to find the mass, molecular mass of compounds. So let's try to find water. Water has two hydrogen and one oxygen. What is the molecular mass of one hydrogen? 1 unit. What is the molecular mass of one oxygen? 16 units. So total you will see 2 plus 16 is 18 units. It's pretty easy, right? So with this you can find the molecular mass of water. Just now we have studied, see, we know the molecular mass of all these atoms. We know that with the formula, chemical formula, the chemical formula actually tells the constituents of this particular molecule, the number of atoms it has. So if I know the mass of hydrogen, mass of oxygen, I can actually find the mass of whole water. See, it is just like that. If I know mass or weight of all the students in the class, let's suppose there are 5 students in the class. Student A, B, C, D. Student A is a girl with 30 kg weight. B is again a girl with 35 kg weight. C is a boy with 40 kg weight. D is a little fat boy with 45 kg weight. And E is very fat guy with 50 kg weight, let's suppose. Small class, maybe 5th or 6th. I want to find the total weight of the class. I have to just sum these, that's all. You add all these, 90 plus 35, 135, 170, 200. So 200 is the total weight of the class. Similarly, if I know the weight of all these atoms, I can easily find the weight of this whole molecule, because we know that one molecule is composed of these many atoms. Let's take some more examples. Let's take nitric acid. I want to find the weight of nitric acid. So nitric acid has 1 hydrogen plus 1 nitrogen plus 3 oxygen. So let's add this. 1 hydrogen is 1, 1 nitrogen is 14, 3 oxygen is 16 into 3, 3 into 60. So how much you get? 63 unit. Okay. Pretty easy. So let's take some more examples. In fact, this is what we have done now. Relative molecular mass of water and nitric acid we just found. For water it was 1 hydrogen, 2 hydrogen, so 2 into 1 plus 1 oxygen, 1 into 16, 18 units. And for nitric acid we just found 1 hydrogen, 1 nitrogen, 3 oxygen. So 1 hydrogen is what? 1 into 1. 1 nitrogen is what? 1 into 14. Oxygen is 16. You add it, 48 plus 14 plus 3, 63. Okay. So let's talk about a term called formula unit mass, same as the molecular mass for a compound, just a new name given. Formula unit mass of a substance is nothing but the sum of atomic mass of all the atoms in the formula. For example, I have the formula of H2O. This formula, whatever atoms you have, you add all the atomic mass, that becomes the formula unit mass. Okay. Typically, formula unit mass, this term is used for ionic compounds. Example, you have, let's suppose, PO4 3 minus. Want to find the mass of this. Okay. Or let's suppose, NaCl. Yeah, NaCl is ionic compound, sorry. I want to find the formula unit mass. So that is 1 sodium plus 1 chlorine. 1 sodium is what? 23. 1 chlorine is what? 35.5. You added 58.5 unit. Okay. So it's just a new term. Thus now we found that the value of formula unit mass for NaCl 23 and this is 35.5. Add this 58.5 unit. Let's find first calcium chloride, CaCl2. This is also ionic, so we'll use the term formula mass for this as well. So it has 1 calcium plus 2 chlorine. So this 40 plus 2 into 35.5. That is 40 plus 71. That is 111 unit. Okay. Let's take some questions. You have to find the molecular mass of these compounds. They are all compounds. Hydrogen, 2 hydrogen, 2 into 1, 2 unit. Let's do some here only. Oxygen, 2 oxygen, 2 into 16, 32 units. Chlorine, 2 chlorine atoms, 2 into 35.5, that is 71 units. You can just use this letter or you can write it. Then we have CO2, 1 carbon plus 2 oxygen. Carbon is what? How much? 12 units. 2 oxygen is how many units? 16 units. Solve it. 32 plus 12, 44 units. Methane, CH4, 1 carbon plus 4 hydrogen. 1 carbon is what? 1 into 12. 4 hydrogen is what? 4 into 1. 1 hydrogen each is 1 unit. You solve this. 12 plus 4, 16 unit. Done. C2H6, 2 carbon plus 6 hydrogen. 2 into 1 carbon each is 12 unit. 6 into 1. And you solve this, you get 24 plus 6, 30 unit. Okay. C2H4, 2 carbon plus 4 hydrogen. Solve this. 2 into 12 plus 4 into 1, 28 unit. NH3, nitrogen is 14, hydrogen 3, 14 plus 3 is 17 unit. Similarly, CH3OH, last one, has 1 carbon, 4 hydrogen and 1 oxygen. So let's put the value. 1 carbon is 12, 4 hydrogen is 4 into 1, 4, 1 oxygen is 16. 16 plus 4, 20 plus 30, 32 unit. So you can easily find the molecular mass of all these compounds. Let's take one more numerical. We have to find the formula unit mass for ZnO, Na2O, K2CO3. See, formula unit mass is used because these are all ionic compounds. It's also given the atomic mass of zinc, sodium, potassium, carbon and oxygen. Pretty easy then, right? So let's find ZnO first. It has one zinc, one oxygen. One zinc is how much? 65 plus one oxygen, how much? 16. To add this, you get 81 unit. Let's take second, Na2O, 2 sodium, 1 oxygen. Sodium is how much? How many? 23. So 2 into 23 because there are 2 sodium units plus 1 into oxygen. Oxygen is 16 unit. So you solve this, 46 plus 16, 62 units. K2CO3. K2CO3. 2 potassium, 1 carbon, 3 oxygen. Right? 2 potassium, 1 carbon, 3 oxygen. Let's put the values. 2 into potassium is 39 plus 1 into carbon is 12 plus 3 into oxygen. Oxygen is 16. Solve this, 48 plus 12, 60 plus 78, 138 unit, and that is the answer. Pretty easy. Okay, so having understood the molecular mass, let's understand the mole concept now. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching. Hello friends, this video on atom and molecules part 12 is brought to you by examfear.com. No more fear from exam. Please pay attention here, little tricky concept here. Let's understand the mole concept. For example, hydrogen will react with oxygen to form water. This is a balanced chemical reaction. Now, to validate this reaction in the lab, we have to weigh hydrogen, we have to find the weight of oxygen, and we have to find the weight of water. What do you think is the minimum amount you can weigh in the lab without using very hi-fi instrument? It has to be in grams, right? You can measure 1 gram, 2 gram, or even milligram, but let's say gram is a standard value. So this way you can do in grams. Right? Weight in grams. But if you remember the concept which I told you, this equation signifies that 1 molecule of hydrogen is reacting with half molecule of oxygen, or let's balance, let's make it like this, let's double this. 2 molecules of hydrogen react with 1 molecules of oxygen to form 2 molecules of water. Okay. So the concept was that 2 molecules of hydrogen will react with 1 molecule of hydrogen to give 2 molecules of water. But actually you can't weigh 1 molecule because the weight of 1 molecule is very, very less. Actually, scientifically it is seen that 1 atom of hydrogen is 1.6 into 10 to the power minus 24 gram. This was done by some scientist, but it is very, very difficult to measure the weight of 1 atom of hydrogen. So in the chemistry we talk about, in the labs we talk about numbers, right? Huge numbers, 1 gram, 2 gram. This is 10 to the power minus 24. Okay. So with this calculation, if weight of 1 atom of hydrogen is this many grams, so number of hydrogen atoms in 1 gram, hydrogen will be how many? 1 by 1.6 10 to the power minus 24, and that is 1 gram by this gram, gram cancel. Solve this, you get 6.2 into 10 to the power 23 atoms. So 1 gram of hydrogen will have these many atoms. These many atoms will actually form, this is less, but a lot of tons and tons of this atom, which is 6.3 into 10 to the power minus 10 to the power 23 atoms, like this piled up will form only 1 gram of hydrogen. Okay, simple maths. Okay, now it is seen that even 12 gram of carbon also has these many atoms. 16 grams of oxygen also has these many atoms. And if you remember, these are molecular mass of hydrogen, carbon, oxygen. Right? This becomes a very unique number because molecular mass, let the general formula, molecular mass grams of any atom has these many number of atoms. You take 12 gram of carbon, 14 gram of nitrogen, 16 gram of oxygen, all these will have this many atoms. Right? This is what is seen experimentally. And if you see the history of this is called Avogadro constant. This number, this is a magical number. Nobody believed it will be same. And if you see the history of this, 1811 actually, Italian scientist Voltas. This is guys Voltas. And in 1811 he proposed that the volume of a gas at any given temperature and pressure is proportional to the number of atoms. That was his proposal. Because in 1811 the chemistry was not advanced. So his theory was a big theory that time, that now we think it is implicit that the volume of a gas will depend on number of atoms. But that time it was not. Number of atoms at a given temperature and pressure. This is what he proposed. Right? Number of atoms or molecules. But the actual proportional value was not determined. In actually 1909, this guy, Jean Perrin, he determined this Avogadro constant. He found that 1 gram of hydrogen has 6.23 into 10 to the power 23 atoms. Okay. So the term mole was used now. Okay. And mole is nothing but molecular mass. If you see the word mole and molecular mass, molecular mass. So from this only this word mole came. So 1 mole of a compound is the molecular mass of the compound actually. Please be with me, it's a new term. 1 mole of compound is nothing but molecular mass of compound. That means 1 mole of carbon will be equal to 12 gram of carbon. 1 mole of oxygen will be equal to 16 gram of oxygen. So this reaction, instead of saying 1 molecule react, 2 molecules of hydrogen reacts with 1 molecule of oxygen, you can say that as well. We can say that 2 mole of hydrogen reacts with 1 mole of oxygen gives 2 moles of water. And we know that 2 moles of hydrogen is what? 2 gram. 1 mole of oxygen is what? 16 gram. So those things we know actually, right? So mole and molecular mass, this relation is something we know. So instead of saying See, all this word molecule, mole, molecular mass all came from the same word molecule. So instead of thinking from the molecule perspective, think from the mole perspective. You see, mole. This is 1 mole maybe. And if this is 6.23 into 10 to the power 24. These many atoms consist of 1 mole. And 1 mole is nothing but this molecular mass, right? So 1 mole of compound is nothing but 6.023 into 10 to the power 23 molecules or atom. When you talk about 1 mole of water, you talk about 6.023 into 10 to the power 23 molecules of water, right? This is 6.023, sorry. Okay, when you talk about 1 mole of oxygen, you talk about these many atoms of oxygen. If you talk about I mean, it all depends if you talk about molecules or atoms. So 1 mole means these many numbers of molecules or atoms, or you just assume molecules itself, no, right? So 1 mole means these many molecules, and these many molecules is nothing but molecular mass, because we have seen that these many molecules or atoms actually gives the molecular mass of the atoms or molecules. So now if you see, things are linked. Instead of talking about 1 molecule or 2 molecule, we're talking about 1 mole, 2 mole or 3 mole. Why? Because these moles actually can give me the grams, and these grams I can easily measure in the lab. This is as good as you have this equation. I'll just show you. So this is the equation you have here. Say 2 molecules of hydrogen react with 1 molecules of oxygen to give 2 molecules of water. You react, you multiply the whole equation with this number, the magical number. So with this I can say that 2 into 6.023 molecules of hydrogen will react with 1 into 6.023 molecules of oxygen to give 2 into 6.023 into 10 to the power 23 molecules of water. So 2 into these many molecules of water is nothing but 2 moles of, this into this is 2 moles of hydrogen, this into oxygen is 1 mole of oxygen, and this number into 2 molecules of water is nothing but 2 moles of water. So if you see, from the molecule perspective, from the molecule view, we are now in the mole view. 2 mole of hydrogen will react with 1 mole of oxygen to give 2 mole of water. Since we are in the mole, we can easily write the grams. See, 2 mole of hydrogen is nothing but 4 grams of hydrogen. 1 mole of oxygen is nothing but 32 grams of oxygen. And 2 mole of water is nothing but 16 plus 2, 18. 18 into 2, 36 grams. So now if you see, directly from the mole I can write the mass. And if you see here, the law of conservation of mass, 4 plus 32, 36 grams on the left hand side, 36 grams on the right hand side. Just understand this concept, very, very important slide for the chemistry. I'll recommend you to pause this video, watch this video 3 or 4 times, 5 times. Make sure your concepts are clear, because this is the basic foundation of chemistry. You understand the mole concept, you understand why we were early talking about the number of molecules, 2 molecules of water, 2 molecules of hydrogen, 1 molecules of oxygen reacts to form 2 molecules of water. This is perfectly valid statement, but very, very difficult to measure mass of 1 molecule. Right? You see, the mass of 1 molecule is so slow, very difficult to measure. You need really hi-fi instruments. We are okay to measure 1 gram, 2 gram. So this guy is Avogadro, and this Jean Pierre came up with the concept of Avogadro constant. And with this, numerically and mathematically, if you multiply this whole equation by 6.023 into 10 to the power 23, there is a golden number. You see that 2 into these many molecules of hydrogen reacts with 1 into these many molecules of oxygen to give 2 into these many molecules of water. And these many molecules of any molecule or compound is nothing but 1 mole. If you talk about these many molecules of water, that becomes 1 mole of water. If you talk about these many molecules of oxygen, that becomes 1 mole of oxygen. These many molecules of hydrogen, that becomes 1 mole of hydrogen. These many molecules of carbon becomes 1 mole of carbon. Very, very good number, magical number, 6.023 into 10 to the power 23. Avogadro constant, very, very important number in the terms of chemistry. Right? So these many molecules actually is nothing but 1 mole. Why this came? Because now 1 mole, the moment I have mole, I can easily write the grams and I can easily validate my statements. 4 gram, 32 gram, 36 gram, very easy to measure in the lab as well. Okay, so please understand why we are doing all this circus is we don't want to measure, or it's very difficult to measure the weight of 1 molecule, but it is easy to measure 6.023 into 10 to the power 23 molecules, and that is nothing but 1 mole, and that is in the grams, and the gram is nothing but the molecular mass. So this formula, that 1 mole of a compound is nothing but these many molecules of that compound, and it is also equal to 1 molecular mass of the compound. This is a very critical formula, very critical observation, and this will be using in a lot of questions. Okay. Since it is a very critical concept, let me write once again here. These many, let's say this is 6.023 into 10 to the power 23 molecules. This is equal to 1 mole, and 1 mole is nothing but molecular mass gram. So for example, let's talk about oxygen. These many oxygen molecule is nothing but 1 mole of oxygen, and that is nothing but 32 gram of oxygen versus O2, right? 32 gram. Let's do the same thing for hydrogen, H2. So these many molecules is nothing but 1 mole of hydrogen, and that is nothing but 2 gram of hydrogen. So you see, this is the molecular mass. This is always 1 mole. You take any compound, it's always 1 mole. You take carbon, this will be 1 mole of carbon, and 1 mole of carbon is 12 gram carbon. Very important concept. Please note 6.023 into 10 to the power 23. Let's talk about molecules now, because most of them exist as molecules. Is nothing but 1 mole of molecule, and it's nothing but molecular mass of. The same formula is true for atoms. 6.023 into 10 to the power 23 atom is nothing but 1 mole of atom, is nothing but 1 molecular mass of atom. Okay. And I also told you why this mole came, because it is convenient to refer the quantity of a substance in the terms of number of molecules or atoms rather than their mass. It's inconvenient. So we have this new term called mole. See why, I'll tell you. The moment I have this reaction C plus O2 is CO2, from this you can tell that 1 molecule of carbon react with 1 molecule of oxygen to form 1 molecule of carbon dioxide. You multiply 1 molecule with this musical number, you get 1 mole. You can say that 1 mole of carbon dioxide carbon reacts with 1 mole of oxygen to form 1 mole of carbon dioxide. Right? Because 1 molecule into this magical number is equal to 1 mole. Right? So looking at the equation, I can just say, but I can't say that 12 gram reacted with 16 grams to give 30 grams. Those things I can't find just by looking at the equation. So it is more convenient to refer the quantity in terms of molecules or atoms. And molecules and atoms are directly linked. Only multiplication factor of this constant number. So that means it is very convenient to write in mole also. But it's very difficult to write in the terms of grams. Just by looking at the equation, you can't say that 13 gram reacted with 18 grams or 19 grams. But looking at the equation, you can say that 1 mole reacted with 1 mole or 2 mole. Okay? And 1 mole, we just told you, that is of any species, atom, molecules, ions or particles. This mole concept is not only for molecule. This is for a molecule, it can be for atom, it can be for ion, it can be for any particles. Okay? So, or any particles. Right. So 1 mole of any species is the quantity that is quantity number having the mass equal to the molecular mass. For example, 2 gram of hydrogen, or 32 gram of oxygen, or 71 gram of Cl2, 18 gram of water. These are all 1 mole. You see, 1 mole. Now all these will have how many particles? These magical numbers, 6.023 into 10 to the power 23. Please note, it is experimentally determined and it is called Avogadro constant. It is all experimental value. Okay. So let me repeat this mole concept once again. See, 1 hydrogen atom mass we have seen was 1 unit, or 1 oxygen atom mass we have seen was 16 unit. Correct? Or 1 water molecule here, not atom, mass we have seen was 18 unit. This is 1 mass of 1 atom or 1 molecule. Okay. Now you multiply this whole thing with this magical number, 6.023 into 10 to the power 23. Hydrogen atoms will be 1 unit into, these will also be multiplied, and this will be value will be equal to 1 gram. Multiply this also. So if you see, this is 1 into this is 1 gram. 16 into this will be how much? 16 gram. Simple maths. This also you multiply. So 1 into 6.0, Avogadro number was 1 gram. So 18 unit into Avogadro number will be 18 gram. And these are nothing but, if you see, molecular mass. So please understand once again, 1 mole is nothing but a pile of 6.023 into 10 to the power 23 molecules, or it can be atoms. That is 1 mole. And this term was introduced in 1896 actually, and this was given by Ostwald. He gave this term, and it's actually derived from Latin word of heap. This is a heap, right? Or pile. So the Latin word of heap is mole, and also it is similar to molecule. That way also, and this term came from this Latin word meaning heap, right? Why? Because the substance is considered to be a heap or pile of atoms or molecules. That is 1 gram. Okay, and that is the concept of mole. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching. Hello friends, this video on Atom and Molecules part 13 is brought to you by examfear.com. No more fear from exam. Let's take some examples to practice. So we have to find the number of moles of the following: 52 gram of helium. See, You have to find the number of moles. So 1 mole of helium is how many grams? Is the molar mass of helium? That is 4 grams. So 4 gram is 1 mole. 4 gram of helium is 1 mole, then 52 gram of helium is how many mole? So 52 gram of helium will be how many mole? So let's do the math. 4 gram of helium is 1 mole. So 52 gram of helium will be how many moles? 1 by 4 into 52 mole. You solve this, you get 13. So 52 gram of helium is nothing but 13 moles. And 13 moles is 13 into 6.023 into 10 to the power 23 atoms. Because we're talking about the helium atoms. Okay. The next is these many number of helium atoms. Find the moles from number of particles. So we know that 6.023 into 10 to the power 23 atoms of any substance, let's take helium here, is equal to 1 mole. So if these is equal to 1 mole, these many number is equal to how many mole? Let's see that. Equal to 1 by the old value multiplied by new value. You solve this, you get 2 mole. So these many particles is nothing but 2 mole of helium. Okay. Let's take some more. So we have to find the mass of 0.52 mole of nitrogen gas, 0.5 mole of nitrogen atom, and these many numbers of atoms. So you have to find mass. Please note, in all these cases you have to find the mass. Okay. So mole is given, you have to find the mass. We know that 1 mole of element weigh molar mass in gram of that element. That means 1 mole of nitrogen gas will be how much? Nitrogen is 14 into 2, 28 grams. That is 1 mole of N2 gas. So if 1 mole of N2 gas is 28 gram, 0.5 mole of N2 gas will be how much? 28 by 1 into 0.5, that is 14 gram. Done deal. The second is 0.5 mole of N atoms. Please note this was molecules, this is atom. So again, 1 mole of N atoms will be how many grams? 14 grams. But the molecular mass of N atom will be 14. Molecular mass of N2 will be 28 because there are 2 N here. So 0.5 mole of N will be 14 by 1 into 0.5, that is 7 gram. Please note that N atoms and N2 gas both are different. Then third is this many number of atoms. So we know that 1 mole of element with this many, we know that, but 1 mole is nothing but 6.023 into 10 to the power 23 particles. These many particles will be 1 mole and that will be molecular mass. So we know that 6.023 into 10 to the power 23 N atoms is equal to 1 mole of N atom, and that is equal to 14 grams, right? So let's ignore this one part now. So we'll have atoms, particles and the weight in one equation now, and that's what you have to find. These many atoms is 14 grams, so these many atoms is how many grams? So these many atoms will be how many? 14 by this value 6.023 into 10 to the power 23 into this value. You solve this, you get 7 gram, and that is the answer. Pretty easy. Let's take some more example. Here we have to find the number of particles. In the last example, we found the mass of the whole sample. Here we have to find the number of particles in a given sample. Here the mass of the gram is given, mass of this is given, mole is given. So we know that 1 mole is 6.023 into 10 to the power 23 particles. For any ion, molecules, atom, doesn't matter. Golden rule. And 1 mole is nothing but molecular mass in gram if you want to find the weight. So the first thing given is 46 gram of sodium atoms. First let's find the number of moles in these. We know that 23 grams of sodium atom is equal to 1 mole. Right? The molecular mass of sodium is nothing but 1 mole. So with this 46 grams of sodium will be how many moles? Obviously 2 moles. Correct? You can do maths. So 2 mole is what? 2 into these many particles. That is 2 into 6.023 into 10 to the power 23 particles. You can do the maths. It will be 1.2044 into 10 to the power 22 particles, or 12.044 into 10 to the power 23 particles. You can do that maths. First part is done. Second part, similar, 8 gram of oxygen. So we know that oxygen 16 into 32 gram of oxygen molecule implies 1 mole. So 8 grams of oxygen molecule will imply 1 by 32 into 8. These many moles? 1 by 4 moles. And 1 by 4 moles is nothing but 1 by 4 into 6.023 into 10 to the power 23 particles. This is molecules, so I can write molecules only directly. You solve this, you get 1.51 into 10 to the power 23 molecules. You can write particles, general word, or you can use molecules. Here it was atom, so I can write atom as well. Done. Third is pretty simple, 0.1 mole of carbon atoms. So we know that 1 mole of anything is nothing but 6.023 into 10 to the power 23 particles. Here we talk about atoms. So 1 mole of carbon atoms will be this many atoms. So 0.1 mole will be what? 0.1 mole of C atoms will be 0.1 into this value. About 23 atoms, and that is nothing but 6.023 into 10 to the power 22 atoms. Okay. The question is 1 mole of carbon atom weighs 12 gram. We have to find the mass of 1 carbon atom. So we know that 1 mole of carbon atom is what? 6.023 into 10 to the power 23 atoms, and this weigh 12 gram. So mass of 1 atom will be how much? 12 by 6.023 into 10 to the power 23 gram. Solve this, you get 2 into 10 to the power minus 23, almost approx. So that is the mass of one carbon atom. Okay. The question is, which has more number of atoms? You take 100 grams of sodium in place, 100 grams of iron in one place, and the atomic mass is given. So to find the more number of atoms, we can just find which has higher number of moles, because number of atoms is directly proportional to mole. We have seen that 6.023 into 10 to the power 23 atoms is 1 mole. So let's find the moles in both cases. So for sodium, 23 is the atomic mass, so 23 gram of sodium is 1 mole of sodium. So 100 gram of sodium is what? Is 1 by 23 into 100 mole of sodium. Approximately 4 mole of sodium. Let's find the moles of iron. Iron is 56. 56 gram of iron implies 1 mole of iron. So 100 gram of iron will imply 1 by 56 into 100 mole of iron, and that is almost equal to 2 mole of iron. This is 4 mole, this is 2 mole. This is 4 mole, that means it is 4 into 6.023 into 10 to the power 23 atoms. This is 4 mole, that means it is 2 into 6.023 into 10 to the power 23 atoms. So which one is more? Obviously iron is more, because this is 4, this is 2. So sodium has more atoms. Sodium is more. Right? It has more atoms. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.